One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and is the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, welcome back to the Inflammation Nation podcast. This is episode 161, and we're still talking about miracle molecules. This is part 2 of a discussion on nitric oxide. And I think what I want to do is just run down through some quick facts, and then we'll talk about some of the roles, I should say, of nitric oxide in the different systems of the body. Because I'm trying to give you a broad overview of all the things that nitric oxide is doing for you. And by corollary then, if nitric oxide is not working for you because you have deficiency or something's blocking its action, this is essentially a list of things that can go wrong for you, which is unfortunately not really a pleasant list. So let's talk about quick facts. First of all, nitric oxide is a gas. In the introductory episode, the last episode, we talked about nitric oxide as a signaling agent. It's a chemical that's used to help communication between different biochemical pathways or different cells. But it's actually a gas. And maybe it seems unusual to think that we have gas in our bloodstream, for example. But when you stop to consider that oxygen is a gas and carbon dioxide is a gas, then maybe it's not so strange after all. Right? Because we do have gases of different types that are dissolved in our bloodstream and they act in different ways. So for example, hopefully you know by now that oxygen is used to help us make energy. Talked about this before with oxidative phosphorylation in the mitochondria and what's called aerobic metabolism, not anaerobic, but aerobic metabolism, which means with oxygen. And it just turns out that we need oxygen as a gas to be present in the mitochondria, or I should say available for the mitochondria, to make the most abundant energy that we can make. But in the process of doing that, as we use oxygen to create this energy source called ATP, we also make something called carbon dioxide, which can be, let's say, I'm going to use the word poisonous, but not necessarily so, but you understand, like we don't want carbon dioxide hanging around in our body in its native form because it will cause some problems. And so our systems are designed to breathe in oxygen, extract oxygen from the air, go through the bloodstream, drop that off at the cell where it makes or uses oxygen to make energy. And then as a result, we make carbon dioxide. And so our red blood cell system is designed to act as a ferry to bring oxygen from the lungs to the cells, drop it off, pick up the carbon dioxide that's been produced as part of the waste material of energy metabolism, and then take that carbon dioxide from the cells back to the lungs where we breathe it out. So we all know that we breathe in oxygen, we breathe out carbon dioxide. Well, guess what? If we don't have sufficient nitric oxide, we can't do that. Not that we can't bring oxygen in, we certainly can, but it turns out that in order for us to drop off oxygen at the cellular tissues or at the tissue site where the cells are, and in order to pick up the carbon dioxide to get rid of it, nitric oxide has to be present. So the literature talks about this being a 3-gas system where nitric oxide, carbon dioxide, and O2 or oxygen all work together to allow us to bring in oxygen, make energy, and then take away the waste material as a result of metabolism. So it's a gas, it's a critical part of the fundamental process of making energy. Our mitochondria require it. Now, nitric oxide, I guess we could technically classify it as a free radical. And I say that because nitric oxide has an unpaired electron. And again, you've heard me talk about free radicals and antioxidants before. Anytime we have something that has an unpaired electron, basically it can bump up against another molecule or part of your cells, your tissues, an enzyme, and it can damage it by stealing an electron, just simply because all these different elements that exist in our body, they like to have paired electrons. They don't like to have these unpaired ones. And so when we have, let me say it this way, nitric oxide, it's a little bit of a double-edged sword in the sense that when it's present in normal physiological amounts, nitric oxide can actually act like an antioxidant, the same way that glutathione or vitamin C or vitamin E does, or astaxanthin. In that, with the unpaired electron, nitric oxide, again, as long as it's there in physiologically appropriate amounts, can take its own unpaired electron and give it away to someone else. Rather than stealing an electron from one of our cells, for example, it actually gives away its unpaired electron and stabilizes a free radical that would otherwise damage our tissues. The problem is that with this unpaired electron and this, let's call it double-minded potential, when nitric oxide is present in too high an amount, like we would see with chronic diseases, chronic infections, especially autoimmune diseases, then nitric oxide stops acting like an antioxidant and starts acting more like a free radical, where instead of donating its free electron or unpaired electron, it borrows or steals one from somebody else. And that's where the damage can happen. And the difference between nitric oxide behaving either as an antioxidant or a free radical, which are opposites, right? The difference is how much is available. And we'll talk about production systems and what constitutes having too much nitric oxide, either a little bit later in this episode or perhaps in a third one. So the bottom line is this: if we make too much nitric oxide, it can cause damage, but when we have the right amount, it actually helps to protect us. Now, nitric oxide as a molecule, as a signaling molecule, has an extremely short half-life. In the blood, the half-life of nitric oxide is, depends on which context is being studied, but let's say certainly less than 5 seconds. And in some conditions can actually be less than 2 milliseconds, which is quite literally just like a flash. Like it's there, it does something, and then it disappears. And I think that the reason why the half-life is so tightly controlled is for the potential of nitric oxide to go crazy and to do things that we don't want it to do. Now, it just so happens that we can actually stabilize nitric oxide, allow it to last longer, and allow nitric oxide to function more like a hormone than anything else. And we talked about this in the first episode, is that one of the many things that nitric oxide can do is you can make it in one place, then it can circulate and go somewhere else, and then it can have an effect somewhere else, and that's what we call a hormone. And one of the ways that we can actually extend and stabilize, or extend the half-life and stabilize the molecule so it doesn't cause damage, is by actually combining it or complexing it with glutathione. Sorry, tripped over my words there. So it's important, obviously, not to just have nitric oxide, but other elements of health in place, like adequate glutathione or glutathione sufficiency. Now, because of this very short half-life, we can't measure nitric oxide with a lab test. However, we can look for, say, signs and symptoms of imbalance or deficiency. For example, hypertension might be a sign of nitric oxide deficiency. I'll explain that coming up in a second. Or we can look for conditions in which we know nitric oxide is reduced, or at least there's a high probability, and that would be things like heart disease, atherosclerosis, the entire insulin resistance spectrum. So all the way from mild insulin resistance to significant insulin resistance to metabolic syndrome to prediabetes and type 2 diabetes, all of these conditions necessarily involve a reduction in nitric oxide, and then increasing nitric oxide levels can actually improve those conditions. But one of the key things, and perhaps what nitric oxide is best known for, is causing blood vessels to relax so that we get improved blood flow. Right? This is what we call vasodilation, where blood vessels, the muscular wall relaxes so it's not so tight, it gets bigger, we get better blood flow. So I think what I want to do is transition away from these quick facts to looking at some of the benefits of nitric oxide more on a system-by-system basis. And really what I'm trying to do is just to give you a big overview. Know that this list that I'm going to go through here is not exhaustive, right? It's just designed to give you a bigger picture across multiple different systems. So we just mentioned blood vessels. Let me just talk very quickly about some other things. We talked about vasodilation, but did you know that the lining of the blood vessels, what we call the vascular endothelium, is actually the largest endocrine or hormonal organ in the whole body. Like you might think, well, it's my thyroid or it's my gonads where I make, progesterone or testosterone or whatever the case is. And the answer is no. It's actually the lining of your blood vessels makes more hormones than anywhere else or anything else. And this vascular endothelium secretes roughly 24, let's say 24, 25 different biologically active substances. Perhaps the most important of which is nitric oxide, for several different reasons. One is this impact on vasodilation, the ability to relax the blood vessels, to control blood pressure, to help form new capillaries. These are the smallest blood vessels that branch off the larger vessels that actually dive into your tissues so that you can bring oxygen and nutrients to your cells and then carry away waste material like carbon dioxide. We've already talked briefly about the role of nitric oxide in our ability to exchange oxygen for carbon dioxide and to control the balance between tissue oxygenation and waste management. But we also see a protective role. We know that nitric oxide can prevent platelets from becoming sticky or activating and forming blood clots. And in the context of things like heart disease, or microvascular disease, we know that nitric oxide plays a role in preventing immune cells from actually sticking to the lining of blood vessels, which can then cause damage and inflammation, which then triggers the growth of plaque formation in your blood vessels that go to your heart or to your brain or anywhere else. Beyond that, we know that nitric oxide actually modulates the contractile properties of your heart. So with adequate nitric oxide, your heart is a more efficient pump. So that's a quick review of what nitric oxide does for your heart and your blood vessels. How about the brain? That's a pretty important system as well. Well, in the introductory episode, I talked about how nitric oxide can modulate or helps to modulate the balance between glutamate and GABA, which are our most excitatory and inhibitory neurotransmitters, respectively. And so nitric oxide is part of how we have that delicate balance between excitation and inhibition. It would be like, an expert driver knows how to balance using the accelerator and the brake in a car to make sure that the car travels the way that the driver wants it to do. And imagine that the brakes don't work or they don't know the brakes are there and all they do is they step on the gas, and if they want to slow down, they pull back on the accelerator rather than simply pressing on the brake. So nitric oxide is part of that balancing act between going forward and slowing down and stopping, for example. We also know that nitric oxide is generally neuroprotective, and that nitric oxide plays a role, with many other things, in forming new synaptic connections. That's the connecting point between neurons. It also helps with neuroplasticity, which is basically a fancy term for how our brain, the nervous system, starts to learn things. We also know that it's involved in the sleep-wake cycle. The centers in the brain that control whether you're awake or sleeping are in part driven by nitric oxide, again, in combination with other things like GABA, for example, acetylcholine, for example. What about the immune system? Well, one of the main roles of nitric oxide, and this is actually where we can start to run into trouble, is that nitric oxide is part of an immune strategy called a respiratory burst. Now, the best example I can give you to understand what I mean by that is if you've ever seen a war movie where a soldier climbs up on an enemy tank and opens the hatch and throws a grenade inside and then jumps down and runs away, and then in the background the tank explodes from the inside. That's what a respiratory burst is. And so we have immune cells like neutrophils and macrophages that use nitric oxide. Basically, they sidle up to, say, a bacteria or a virus. They create a hole and inject some nitric oxide in there, and that nitric oxide actually explodes the pathogen from the inside out. So it's a critical part of the immune system and how we deal with foreign invaders and things that shouldn't be there. In the gut, nitric oxide can prevent leaky gut by protecting the gut lining and helping to regenerate it when it's been damaged. Because it's a signaling molecule and actually used by neurological tissue, it can actually help with gut motility, meaning that if your nitric oxide levels are low in the gut or in the brain centers that control the brain-gut axis, then we can see things like constipation. Mentioned hormones a couple of times. We know that up in the brainstem, the part of the hypothalamus that controls your thyroid, your adrenal system, your reproductive hormones, all of these are regulated. Like that central command center for all of your major hormones is in part controlled by nitric oxide. And we know, for example, that nitric oxide and insulin sensitivity are directly correlated. And we could go on and on and on and on, which is why I said I just want to give you a big overview of how nitric oxide functions in your body in different ways, so you can start to clue in that, yes, this indeed really truly is a miracle molecule. Now, I've mentioned before that because of the very short half-life, we really don't have any reliable labs that measure nitric oxide. And this will make more sense in a moment, but there is a saliva test strip that can indicate nitric oxide levels. Basically, you work up some saliva in your mouth and you put this test strip in and expose it to the saliva. And after a period of time, it changes color and it will tell you whether or not you have adequate amounts of nitric oxide. But at best, this only shows half the picture. I'll come to that here in a second. So what we're left with in the absence of a lab test, like you can't measure nitric oxide, like how much glucose is in my blood, we can figure that out. How much thyroid hormone do I have? We can figure that out. But we can't figure out by doing a blood test or a urine test, or even, truth be told, the saliva test, because it doesn't show the whole picture. We can't get a quantitative analysis of our nitric oxide levels. So what we're left with, what we have to fall back on, are indirect indicators of either other things we can measure that are somehow related to nitric oxide, or by looking for metabolic conditions like insulin resistance, prediabetes, heart disease, autoimmunities, hypertension. We can look at conditions where we know these are linked to changes in nitric oxide levels or functionality. Now, before I share those tidbits, I want you to understand, because I don't think I pointed this out in the first episode, is that we all start losing nitric oxide as we age. Great. One more thing that I have to worry about, right? If you listen to my whole my series on exercise, particularly with resistance training, you know that basically once we're past the age of 40, every year we lose a certain amount of muscle mass and strength and power, and that's part of our eventual or gradual decline and our march towards frailty and loss of quality of life, unless we do things like resistance training to maintain our muscle and hopefully even grow it and make that better. And nitric oxide is really no different. Starting actually about 20 years old, we lose roughly 10% of nitric oxide production and endothelial function every 10 years. So from 20 to 30, we drop about 10%. 30 to 40, we drop another 10%, such that by the time we're, say, 50 years old, we may have lost up to 50% of our ability to make nitric oxide. And, all we have to do is look at blood-related things, like the increased incidence of things like heart disease, hypertension as we get older. Part of the reason for that is because we're losing nitric oxide capacity and it's not doing what it should be doing for our heart, for our blood vessels, for our brain, and so on. Another way to understand this is to look at the fact that 50% of men over the age of 40 have signs of erectile dysfunction. And we've known for quite a long time that erectile dysfunction is not really a hormone problem, which a lot of guys think, well, it must be my testosterone. Sometimes that's involved. But we know that most cases of erectile dysfunction have to do with blood flow and nitric oxide. And if you look at the prescriptions of things like Cialis, those are nitric oxide enhancing drugs. ED drugs are basically working on the nitric oxide pathway because blood flow is the key to erectile dysfunction. Now, I'm not saying that because I want to turn this conversation towards that, but it's about looking at the realities of aging and starting to key in the things that are are going to change on a predictable pattern, and then asking yourself, do I want to do something about this or not? Like, if you're beyond the age of 40, I can tell you that you're losing muscle mass unless you're already lifting, doing resistance training. I can tell you, whether you're a man or a woman, if you're in your 40s, your 50s, even in your 30s, you have lost a certain amount of nitric oxide. And that means you lose all of the protection, all of the good things that it does for us. So let's talk about some simple indirect lab markers that we can measure. And I'm just going to focus on one because this is a relatively new area where we're starting to understand all the different pieces and how these things connect. But one of the easiest things you can do, and this is something that I measure on all of my clients, it's called homocysteine. Homocysteine is, it's normally talked about as an independent risk factor for heart disease, and that's true. Homocysteine is part of your methylation cycle. So if you know what homocysteine is, chances are you probably learned about it because you listened to someone talk about methylation and the importance of that. With high homocysteine, what ends up happening, it's kind of like a two-step process. With high homocysteine, we increase the production of something called ADMA, or asymmetric dimethylarginine, and that's something we can also measure. And that increased ADMA then leads to a decrease in the production of nitric oxide. And so what we can do is kind of back that up and say, well, if nitric oxide can go down because ADMA goes up, and ADMA goes up because we have high homocysteine, then anytime you look at your labs and your homocysteine levels are elevated, you can theorize, because of the biochemistry and the predictability of this, that you probably have a problem with nitric oxide. Now, this does not guarantee that if your homocysteine levels are normal, so too is your nitric oxide. It doesn't work that way because there are other factors that can interfere. All I'm saying is, if you're looking at your labs and your homocysteine levels are high, you should start to question whether or not nitric oxide is being compromised. And I will say more than often, yes, it is. So what is high homocysteine? Well, it depends on who you ask. Don't go by the lab range, because the lab range is just simply an average of people getting their blood tests done, many of whom have high homocysteine for one reason or another. It could be genetic. It could be a change in some kind of a chemical pathway like the methylation cycle, or it can be as a result of metabolic abnormalities. But if we look at the literature in neurology and cardiovascular disease, we know that when your homocysteine levels are double digits and above, we have problems. In fact, we have plenty of compelling evidence that suggests that once homocysteine is consistently, say, above 7, then over time we see increased rates of neurodegeneration. So think things like dementia, Alzheimer's. That really kicks off when homocysteine levels get to 15 and above. So my general guideline, this is what I use in my own practice, it's what I teach other doctors to look for, is you want homocysteine at the very least to be single digits, so under 10. And ideally in the long run, you want homocysteine levels to be 7 or below. I would say the functional range is 4 to 7 for homocysteine. Now, labs will routinely say that the upper limit of homocysteine is 15 for some labs, it's 11 for others, and it's 20 for different ones. So just ignore the lab range. And your first goal, if your homocysteine is elevated, is it should be single digit. Now, how do you get homocysteine levels down? Different strategies. Sometimes it corrects itself just simply because you get healthier in the bigger picture. So sometimes you don't need to do anything directly for it. In other cases, you might need to take some kind of a methyl support or methylation support, whether that's in the form of methylcobalamin or methylfolate or trimethylglycine or betaine. All of these things have been shown to be effective in the literature, and I can testify just with my own patients, my own clients. I prefer to use the word client than patient, that this methylation support can change it. So how do we look? Easy thing, just look for high homocysteine. If you have high homocysteine, you can be pretty sure that nitric oxide is being compromised. Now, aside from that, I mentioned the saliva test. And the saliva test has been around for, probably at least 10 years, maybe a little bit more than that. And as I mentioned before, you just work up some saliva and you put this little test strip in your mouth, and it changes color based on how much nitric oxide you have in your mouth. Now that brings into the conversation, well, how do we make nitric oxide? Well, there's two different ways to do it. Each one is responsible for roughly 50% of the total nitric oxide you have in your body. So one method of production is what we call the oral production system, or the oral route or route. And the other one is what's called the constitutive route, which is enzymes in our body that make nitric oxide. So I'm going to walk you through these very quickly. I don't want to change this in or turn this into like a massive discussion on biochemistry, although I'll throw some of that stuff in there. But here's what you need to know. First of all, let's talk about the oral route. When you consume foods that have naturally occurring or even added nitrites and nitrates, and I know that you've been conditioned to go, well, nitrites and nitrates are bad for me. So, if I, for example, if I buy a hot dog, I better get the nitrate or nitrate-free one because that's healthier for me, because I don't want the nitrates and nitrites. Now, to be honest, that's thinking dating back to the 1950s. It is outdated. It is not scientifically correct. I'll just leave it there for perhaps a different day. But when we consume foods that contain nitrites or nitrates, a lot of those like naturally occurring ones are going to be in the greens that you eat in your diet. As you chew those, there are certain strains of bacteria that are on the back of your tongue that are part of your oral microbiome that can take these nitrates and nitrites and metabolize them into nitric oxide. Now, we as humans do not have enzymes that are capable of taking nitrates and nitrites and converting them to nitric oxide, but the bacteria on the back of your tongue can do that for us. And so one way that we get nitric oxide in our system is to have good oral health, that when we consume naturally occurring nitrates or nitrites, or even foods that have these added to them as preservatives, and I'm telling you, you should not fear those. But as we eat those things, the bacteria on the back of our tongue metabolize the nitrates and nitrites, they make nitric oxide, and we swallow that. Now, we eat something and we swallow it sometimes seconds later, so all of the nitrates and nitrites that don't get metabolized just simply get swallowed down into the stomach. And as long as we have an acidic environment in the gut, then we can convert the unmetabolized nitrites and nitrates that we swallow. As long as we have an acidic environment in the gut, that hydrochloric acid sufficiency can then help to convert the stuff we swallow and metabolize that in the gut and create even more nitric oxide. And remember that this oral pathway, or this oral production route, accounts for roughly 50% of all of the nitric oxide we have in our system. So it kind of begs the question, do you have adequate nitrates and nitrites in your diet? It might beg the question, like, should we be eating greens? And should we be looking at, now don't take this as an endorsement, but let's say we're eating hot dogs. We're eating deli meat that has been processed and is preserved with nitrates and nitrites. We actually turn that into nitric oxide, as long as your oral health is appropriate and you have good stomach acid. So here are some of the takeaways. Number one, oral health is critical. That means a couple of things. Number one, do not use mouthwash. We actually have studies that show that people who use mouthwash destroy all the bacteria in your mouth. In fact, I interviewed one of the top researchers. I think I mentioned him in the last episode, Dr. Nathan Bryan. And I'm probably going to have him on the podcast here at some point, and we'll talk about this from his perspective as one of the top researchers in the world and as an inventor and creator of several nitric oxide products that are now being used worldwide. But basically, he says that, like when Listerine says that it kills 99.9% of all bacteria, he said, you better believe it. And that includes the bacteria in your mouth that are there by design to metabolize nitrates and nitrites from our diet into nitric oxide so we can protect our heart and our brains and our hormones and everything else. That's pretty important. So number one, don't use mouthwash. Number two, do use a tongue scraper, or at the very least, brush the back of your tongue when you brush your teeth, because these bacteria live in the little furrows on the back of your tongue. And when you use a tongue scraper, which you can buy on Amazon for a couple of bucks, it's not expensive. Or when you brush the back of your tongue, it disturbs that environment, almost like plowing ground or soil, preparing soil to plant seeds. And so we have studies that show that people who brush their tongue or use a tongue scraper have better oral bacteria and better capacity to make nitric oxide naturally. And then finally, we have to have an acidic gut. And many of you listening, I know your stomach isn't working the way that you want it to. There could be many different reasons for that, but you need to watch out for things like thyroid issues. We know that people with thyroid issues pretty much across the board don't make enough hydrochloric acid. If you have infections in the gut, any infection really, but particularly with the bacteria called H. pylori, will decrease your stomach acid production. And one thing you can simply do is just ask yourself, like, what is my ability to digest and tolerate proteins in my diet? Like if you are someone who stays away from heavier, denser meats like steak or pork or veal or whatever, and you opt instead for chicken and fish because it's easier to digest, or if you feel like if you have a meat-heavy meal and it sits in your stomach, don't ignore that. Basically, what you're seeing there is you're seeing signs and symptoms of maldigestion, probably rooted in low hydrochloric acid, rooted in some other mechanism. So don't just change your diet to accommodate what you can digest and don't eat the things that you can't. Figure out what the problem is, right? So number one, oral health is critical. Don't use mouthwash. Do use a tongue scraper or brush the back of your tongue, and make sure that you're finding and fixing anything that leads to a protein maldigestion or protein intolerance, whether that's a thyroid issue, gut infections, a SIBO problem, or anything else, right? That's important. Now, the second way that we make nitric oxide, and I'm just going to give you the 2-second summary here, and I'll save the rest of this for the next episode. The other part of the other side of the coin, the other 50% of nitric oxide production we have, comes from what's called the constitutive system, which is an enzyme-based system inside that takes the precursor amino acid called arginine and converts that into nitric oxide. So remember, we have, like as humans, we don't have the enzymes that convert nitrates and nitrites into nitric oxide. That's why the bacteria in the mouth are so important. But we do have enzymes called nitric oxide synthases in our bodies, in different places, in our brain, in our blood vessels, and as part of the immune system, which can take the amino acid arginine and turn it into nitric oxide. And again, this is critical. This changes as we get older, and the balance and capacity of these enzymes change with different types of metabolic issues, just simply being unhealthy. All right, guys, I'm going to leave it there. Thank you for listening. We'll be back with a third episode, and we'll finish off our discussion about nitric oxide as our first miracle molecule right here on the Inflammation Nation.
Thanks for listening to Inflammation Nation. If you enjoyed this episode, make sure you subscribe to our podcast. Be the first to know when a new episode drops so you can stay on top of your game. It also helps others like you find the answers they need. You can use the links in the episode description to check out Dr. Noseworthy's self-learning programs for thyroid, detox, and gut health. Or you can submit a question for the podcast and even reach out to Dr. Noseworthy directly.